Hey folks, my name's Matt Kulukundis, and actually, I realized when writing this talk, I can't provide a guaranteed script for you. But I can tell you about my journey and how I grew my toolkit, including tips, tricks, pitfalls, and things like that along the way. The times I've run through this talk, it ends up coming in around an hour, so feel free to get really audience-y on me. Bring the C++ now experience. You're mic'd.
You'll regret that.
Yeah, I will. But so this is the slide I really hate most in a presentation, where I'm going to talk about myself a huge amount. And I would prefer to just dive straight into technical bits of code. But one of the problems with large-scale migrations is that they're, by their definition, large scale. And so you kind of have to talk in patterns and generalities. And you're going to see, in the course of just talking about myself a little bit here, there's some significant jumps in complexity and scale along the way. And I'll try to call them out to simplify things. Early in my career, I was working on a compiler and did the thing in Andy's talk in the upper right corner, change the signature of a virtual function in a compiler. But the code base, it was tiny and small, right? 300K code base, the whole thing fit in an IDE. When I came to Google, I renamed a concurrency primitive. It had 100 uses. That's nothing. The only thing that was interesting was Google Scale and stuff. I joined C++ core libraries, and they were like, hey, we want you to change how all of Google does error handling. That was a jump in complexity and scale. And I got bored doing that while I was doing it. So I said at the same time, what if I replace all the hash tables at Google? So some of these interleave in time in weird ways, but I'm gonna pretend that they were all sequential, just like my concurrency. And then at some point, I replaced PCRE, pro-compatible regular expressions, with RE2. After that, I moved to lead protobuf, and there was this question of how do we deal with the mass of protobuf's legacy debt, and how do we design things to be migratable? And that brought together a lot of my history and experience. And then I founded BrontoSource in late September to automate software migrations. We are hiring, and if you have automated software migration needs, especially in the world of C++, please come find us. I have email, LinkedIn. Once I actually release the slides, that LinkedIn is actually a link. So I'm told that presentations need an overview where I warn people what's going to happen rather than just inflicting my meandering mind upon them. And I will acquiesce, but I want it on the record that it's under protest. Obviously, we're going to start with some definitions. Then we move on to the kind of tools we can use to make these changes. Then we're going to get to the heart of the matter, which is how did it go in practice? What were the experiences? And then we're going to close with a little bit of lessons about it, but mostly it's just going to be Q&A and stuff. I'm going to start with the most important definition for this talk. This is Charlotte Bronto. Charlotte was designed by Dave Zalagi down here. He's a really cool artist. He's actually best known for creepy Pokemon. Check out his work. It's kind of awesome. Charlotte is a bit out of norm for him. I really wish I could fill this talk entirely with art that David has done. And for the record, we did pay him for the work that he did do, but he actually also has a day job. And so he wasn't able to do all the art. Fortunately, you can use AI to generate kind of near matches of the Bronto family, and the Brontos have a very large family. So you'll see that throughout this talk a bit. And for the record, I had an explicit conversation with David about using his designs to feed into generative AI art. And that's the base level of respect we owe creators. So in order to get to the definition of migrations, of automated migrations, we're really going to need to define a few of the underlying concepts. Refactoring, according to Martin Fowler, a change made to the internal structure of software to make it easier to understand and cheaper to modify without changing its observable behavior. And then there's a verb form that's just actually doing it. Fowler says without changing its internal behavior, but he doesn't really mean it. At some level, all behaviors are observable. I'm no longer contractually obligated to mention Hiram's law. Now I mention it out of love. Hiram formalized this with what he wanted to call the law of implicit contracts. Much like Matt Godbolt, Hiram lost that fight, and we all know it's Hiram's law. So now that we've addressed the Hiram in the room, it's interesting to note that Martin would not consider fixing a memory vulnerability to be a refactor or optimizing CPU performance. Fowler focuses deeply on make it easier to understand and cheaper to modify. So anything that has an ulterior motive doesn't count, which is really weird in my world, because this means I could switch from C++ to Rust and that's a refactor. But if I'm upgrading a third-party dependency because of a CVE, that's not. And I don't really like that. I'm just gonna strike that part of the definition. I think this is the way folks usually talk about it. And refactors are about changing the internal structure of software for some purpose, because it could be to make it easier to use, it could be to close a vulnerability, it could be to optimize, but it's about the internal structure and not the deliberate feature set of the software. And if you disagree with me on this, fight it out in the YouTube comments. You're just driving my engagement numbers. So now that we've cleared up that definition, Titus kind of took Martin Fowler's ideas of refactors, because Martin Fowler had a whole categorization of here are the primitive refactors, a list of 20-ish. And Titus took them a step further because Titus observed some of these can only be done in a single commit, PR, whatever you want to call it. And some of them you can do in a whole bunch of small changes. These were all in his 2019 CPPCon talk, Maintainability and Refactoring. I personally prefer the term atomic and non-atomic for these types of things. You cannot split an atomic change, whereas a non-atomic, you can split into its atoms.
If you split the atomic change, it explodes.
I mean, half the time if you split the non-atomic change, it explodes. So Titus went on in his talk to explore situations where non-atomic refactor is literally not possible. For example, if your code base is too large for you to commit in a single version, or if you are a library and you have hundreds of users in different Git repos, you can't actually make a commit simultaneously across 2 Git repos, unless you have a third Git repo telling you which versions of those 2 repos are the things. And this way lies that whole database technique that I'm drawing a blank on the name of. So this should give us enough space to define a migration. Migrations are a sequence of single or multi-step refactors that move an entire code base from one state to another. What distinguishes these from a multi-step refactor is that a migration might contain multiple different multi-step refactors or single-step refactors in it. Consider the migration required to upgrade a library. Let's imagine someone discovers a major CVE in our super important libawesome. We're naturally going to start by cursing whoever brought this dependency in and left it in a state where it hasn't been upgraded in 5 years. But we do know our goal. We want to upgrade the library, but doing this is going to require 6 steps. The 3 was foreshadowing. Add shims. We'll say, because this is a major version break for libawesome, they removed some functions. So we're going to need to create our own functions that build the new behavior off of, in version 2.1, they're going to call the old functions. We might have an ifdef in there to call the new ones in version 3.7. After we got the shims, we have to find everyone who was calling the old methods that we're doing, and we're going to switch them over to use the shims. Then we can actually switch the library, which was actually what we wanted to do. Now, we update the shims because they no longer need that fallback path to call 2.1. Now we want to clean up after ourselves, so we inline the shims everywhere. Finally, we remove the now no longer used shims. Steps 2 and 5 here are themselves potentially quite large multi-step refactors. But worst of all, step 3 was our actual goal. So it could be you finish step 3 and your manager's like, nah, man, we're good. We accomplished the goal. And like your code base just like slowly grinds down this way. Code bases are littered with these half-done migrations. And the best way to avoid this fate is to reduce the cost of those last 3 steps, of those migrations. You want to reduce them as much as possible. My co-founder, Andy, had a really good talk this morning. If you're on YouTube, you should just stop watching this talk and go watch that talk, because it's awesome. But please come back. I need the engagement. I live for the engagement. But that's the real answer here, is you need to make it so low cost that the pointy-haired manager will never say, stop, we accomplished the goal. Speaking of tooling, I'm going to need to build this sort of foundational concepts that I like to think of as Maslow's hierarchy of needs for code base health. Version control. If you don't have version control, go have version control. Like, I don't know about you folks, I version control my dot files, I version control everything. Like, please, go have version control. Once you have version control, write some tests. It'll help you. When I'm doing a 3-day hackathon, on day 1, I'm writing tests. On day 3, I'm deleting tests. But that gives you an idea. Tests pay off that fast. Once you have tests and a couple of people, you're going to want some continuous integration, something that can just run your tests automatically. And the other thing that continuous integration does is it forces you to have a build that can kind of just work and is not just on my machine. Once you have all of this foundation, you can build automated migrations. Actually, there is something more important than version control. So automated migrations are often a fundamental shift in mentality. You're no longer going to treat your changes like pets, where you care about their well-being and you want each and every change to be submitted. You should now consider the health of your overall herd. Look for ways to make edits large scale, filter patterns of these edits large scale, simplify the targets. Look for ways to do things en masse, and if one of them gets sick, well, you take it behind the shed. Patterns are the key to almost everything in large-scale migrations. So now let's think about what tools are we going to be using for recognizing patterns and doing all this stuff. And the following list is not going to be exhaustive. It's just here to get you started, because really, in the world of automated migrations, especially when you're pushing yourself, like any port in a storm, the command line tools of yore are often exactly what you want for this sort of thing, right? Find, xargs, grep, ripgrep. Ripgrep is like grep, but on steroids. It's really good. I highly suggest it. Kind of combines find and grep. Sed, awk, or if you were born after 1980, just Perl.
What if I was born after 2005?
Just Perl. Right? These are all just amazing command line tools. It turns out the command line tools of yore, they were onto something. They were onto a lot of things. Parallel, this is GNU Parallel if you don't know it. It's kind of like find pipe xargs, except it just parallelizes everything. And it works at scale, surprisingly. I successfully used Parallel in Google's codebase. And so you get this common pattern here of oh, I'm going to use some tool to find the pattern that I care about. And this is just identifying what files you kind of want to modify. And then I'm going to use some other tool to actually do the substitution that I want. This is the real pattern. And honestly, if you have some relatively uncommon names that you're trying to work with, like return if error and log with prepend, or COP black shoals, this sort of just regex it. It's surprisingly effective.
You have an audience heckle waiting.
It's not a heckle. I was just pointing out, in your hierarchy, you might have folded that into version control, but code visibility is
Yes.
actually pretty critical.
Yeah. If you don't know where your code is, that's great. You don't have any code.
But a lot of people don't know that at the organizational level. It's like, what do we need to do to get fast? Like, well, first, you need to get, I can't run a grep on your code because I can't run a grep on your code.
100%, right? And like there are, I really don't want to scare everyone in this room, but there are major companies that handle your money in your cars that do not know where their code is.
It's 11 o'clock. Do you know where your code is?
Yeah. But like sometimes that like all of these command line tools and stuff, they're not enough. You need all of the precision. And you can build on the Clang AST for this. Clang's AST matchers, they're great. They give you like access to the full AST, access to the preprocessor, like everything at the cost of a world of pain. Kristen Shaker has an amazing talk on it's her CPPCon 2023, how to build your first C++ automated refactoring tool. It's great. It walks you through it. At Google, we had a very rough rule of thumb that like if you have somewhere between 200 and 500 instances, like if you have less than 500 instances, like don't write a Clang tool, just like hooker by crook, regex this stuff. Because like that's how bad the learning curve is. And if you have like 20 instances, like just throw up a NeoVim. So that gives you a sense where the break-even point for Clang tools are. And when the overhead of Clang tools are just not worth it, you can get away with more textual pseudo-parses. And there are a whole bunch of tools for pseudo-parses. And what all of these tools lack in correctness, they make up for in availability and speed and a gentler learning curve. Really honestly, there's only one of these tools that I have a ton of experience with. I'll let you guess which it is. But like little tricks like this, like here's a regex that often will swap two arguments to a function. Is it correct? No. If my function is called 100 times, it'll probably be right 90 of the times and I can fix the last 10. Like often, right? It's getting good with these tricks. They can really save you time.
We call that semi-automated workflows, right?
Yeah, absolutely. I'm like, actually in here, AI is a kind of good semi-automated workflow.
Yeah.
It's a little harder to set up and you can't quite trust it as much, but like it's there and it'll probably get better, they tell me. Large migrations are by their very nature multi-step refactors. So you need to find a way to lock in incremental progress and prevent backsliding. So what do I mean by backsliding, right? As I'm doing this migration to the code base, there are innumerable other developers at the company. Actually, you would hope the company can enumerate its developers, but much like it can't enumerate its code base sometimes. But they're all just submitting code willy-nilly, often doing the exact opposite of what you want and giving you more work to migrate. And so you need to figure out some way to lock in your progress and to stop it from being an infinite pile of work. This is from Switch, how to change things when changes are hard, right? Big problems are rarely solved with commensurately big solutions. Instead, they are most often solved by a sequence of small solutions. And this can be really simple ways to lock these things in, right? Like you can just mark them as deprecated. Most developers actually really hate it when a deprecated thing shows up in their code review and then the code reviewer is like, hey, that's deprecated, right? Sometimes if you're in a version control system that has access lists, you can just put an allow list on the existing users and prevent new users. Sometimes this goes so far as like you have to publish guidance about like best practices and like give talks. Understanding how to lock in your wins will be vital in the long run. It is important to note that simply doing the migration faster is rarely going to work and is almost never sustainable. Like, I'll admit, sometimes I've worked over Christmas just to like, hey, no one's developing there and I don't actually like Christmas because reasons I'm not going into on YouTube. But like
engagement though.
Yeah.
No.
If you like Christmas, get in the comments.
Yeah. Take it to the comments if you want to tell me I should like Christmas.
So you like CMake too?
I will never.
I don't know if you like comments, I'm just saying.
Yeah. But that's a recipe to burn out. And this game is about sustainability. So I was on the flight here, and I was deeply offended to realize that while they had Back to the Future 1 and 2 on my in-flight console, they did not have Back to the Future 3, which is one of the finest works of cinema the world has ever produced. It was robbed for Best Picture by Dances with Wolves. Like, come on. Didn't even get a nomination. I can't believe the Academy. One of the moments that really stuck with me all these years later was Doc Brown was explaining that you have to think four-dimensionally. And so they had this great plan. They're going to push the DeLorean because they've run out of gas or whatever, and they're stuck in the Wild West, and they're going to push the DeLorean with a train towards a bridge that's not finished and still under construction. It's just a giant chasm. And Doc Brown is explaining, if we get it to 88 miles an hour, it'll work to the future and then coast across the bridge, which will have been finished well in the past. And weirdly, you can do this with large-scale migrations and refactoring tools. As I mentioned, I used to work on a compiler. Please don't hate me that it's Java. It was a Java-based compiler targeting the JVM. And it had a really deep class hierarchy. It had hundreds and hundreds of subclasses because we had a lot of special forms in the compiler that each one was a subclass of another thing. I'm not saying it was well architected. And it used a lot of recursive calls through this tree. And at some point, we realized we needed to add a context argument through all of the calls in the recursive tree. Fortunately, our codebase fit into the IDE nicely. In my case, this IDE was Eclipse, and Eclipse has a powerful refactor. There's a dropdown that allows you to add an argument with a default, right? And then this will compile in all the places because the default is just passing through, except for where you start the recursion. In other words, everything coasted over the completed bridge because the edits depended on themselves throughout the recursive tree. And I really like that. In terms of what tool did I use for this? Okay, I used Eclipse. This is a formal, it's basically like Clang except flavored with a cuter dyno. And I tell this story not because this was a large-scale refactor, 300,000 line code base, not that big. I tell it because this is what set me on the path to really getting me hooked on refactoring. I was like, oh man, if I suddenly treat code as the data, I can just do anything. And it's such a fun superpower. Once you get used to thinking this way, you approach problems differently, and every once in a while you run into someone who's doesn't know Kung Fu, and they're like, it's amazing. So early in my career at Google, I came to the situation where I needed to access this class called blocking ref count. And for really annoying technical reasons, that class was in a util directory that I didn't have access to, and so I needed to move it to a concurrent directory. And I figured, while I was at it, I'm going to remove this fork of blocking ref count that I found because, I'm a good person. Why are you laughing? So do folks here have any idea what the best tool for this job is? Right? Note that blocking ref count is a relatively uncommon name. Anyone?
Control F.
Right. I hear grep over there, Control F. Right? Absolutely. A regex is the correct tool to use for this. Here's the regex. Boom, you're done. It's not that hard. This is also not remotely what I did. I had just gotten a taste of Kung Fu, and I wanted to do it at scale at Google. So I spent 2.5 weeks writing a fully configurable Clang tool that would allow me to rename one class to another class. It was super fun. I also was texting, the author of Clang format at what I later realized was late in his evening, and he's just answering from a pub in Berlin. It was great. And the hardest part of this was working with the Clang types. Types in the Clang AST are the most neglected part of the Clang AST. Avoid them if you can. And they're really super complicated in the Clang AST. Even before you get into the source of the real technical challenges, This type is part of a template instantiation, but it is not dependent on the template types themselves. You're like, remember, like I said, you would get a world of pain? Here's your first taste of the pain. In the end, the migration was actually really easy. The hardest part was that I insisted on using a more complex tool than I really needed. But like, I actually had fun with it. And if I had it to do again, I would take the hard path, right? If you've got the space and the time to take the hard path but learn a really cool tool, do it. Like, when I first joined C++ libraries, Google's error handling libraries, they were in I'm going to politely call it a sorry state. There's a very popular idiom. It was a macro that would propagate errors automatically. And it had a couple of variants. In fact, it had 20 variants. Well, 17 if I'm being really honest. Also, because this library was not provided by the official libraries team, it had 50 forks. And each of those forks had a different subset of these variants and a few of their own extensions, because, why not? So, by the way, for anyone who's ever designed a macro-based library, I'm going to warn you, this is slideware. Do not use this code. Like, these macros that you see here will misbehave in real code immediately. Like, this if will pick up an else above the returnif error and turn into an else if in a way you don't want. Like, designing a proper macro-based library is very, very difficult and fraught with like weird things you do not expect.
Also, log an error will expand the replays.
Yep.
I'm not remotely surprised. Oh, probably because I double evaluate message or something.
Because you need to prefix every macro with some sort of scope thing.
Yeah.
That's a nice refactor too, by the way.
Yeah, exactly. So like, don't do this. This is like not thing. But suffice to say, many of the 50 forks, they had these issues. So here's kind of what the usage would look like for these things. And the refactor is a bit easier to see from usage, right? Okay, we're going to like, boop. And then like, we're going to simplify again, right? This is not that big a deal. I'm also going to skip the part of this story where I designed the API that we're migrating to. And then I worked with all the stakeholders to make sure that they were on board with the design that we were migrating to. And that was contentious. But like, that's all before you get to the migration. This is the talk about migrations. So let's take a moment to strategize our plan of attack on this migration. Some of these libraries have almost no usage. It comes from having 50 duplicates of 17 variants. For the most obscure things, anyone guessing what we're going to start with here?
Right.
Nailed it. Just throw some regexes at these things. But like, this is the most popular error handling library at Google. It's used in like 1 million places. So we're actually going to need the full Clang tooling. So you might say like, why am I going to start with grep if I'm going to need the full Clang tooling anyway? And this is probably a good moment to talk about what I mean by like make progress and where automation fits into everything. Thus far, I've kind of just talked about like, how do you generate changes? And then like, I don't know, God comes and the changes do something. Like, and what gives, right? What do I do after I get the changes? Because getting the changes is only the beginning of the process. Inside Google, there's a tool called Rosie. And we would use Rosie to like manage and submit a huge number of CLs. And that, remember this, our hierarchy of needs? What was the reason why we have these first 3 layers? And the reason is, so Rosie can stand on them, right? Rosie will just take the patches and apply them and build them and test them and revert the ones that don't. And like, this is the automation that you need. And if you're like, well, I don't have this kind of automation. Rosie started as a Python script that ran on a local work machine. It really doesn't matter as long as you can kind of just do it in bulk to begin with. So don't be afraid to just like get started and throw this stuff into some shell scripts. Once again, like, man, the tools from IBM back in the day, like. But I digress. Back to the story at hand. In this case, I used some very quick and dirty regular expressions to give Rosie a bunch of changes to chew on, because I knew that building a Clang tool is going to take me a little while. And so why do I want Rosie chewing on changes while I'm building the Clang tool? And it's an interesting question. Also, like, I'm also kind of hopeful here, right? I just learned that whole big Clang thing to like rename all the classes and stuff. Surely that is going to help me with building this Clang tool. Narrator, it didn't. For relatively predictable reasons, the preprocessor and the AST are just like entirely separate parts of Clang tooling. So I had to learn an entirely new set of APIs in the Clang library. Fortunately, the preprocessor APIs are way simpler, like way less pain than the AST itself. But like, I haven't answered why did I load up Rosie with a batch of shoddily made changes in order to, while I'm working on this other stuff. And it's not actually just pipelining it to consume as much of Rosie's capacity as I can. Hiram's law is real, but it affects migrations slightly differently. And so getting early exposure to your migration will help understand where the unexpected complexity in your migration is. This migration had 2 wildly different speed bumps with surprisingly different resolutions. The size on stack of return if error grew from 8 to 24 bytes. You're like, okay, that's not big, that shouldn't matter. But Clang, in debug mode, doesn't reuse stack space for locals, or at least it didn't. Maybe it's gotten smarter now. And I think it still doesn't because it helps with like GDBing stuff to not have the cross-contamination. And so some tests were actually sensitive to this, because if you've got a method with like 70 calls to return if error, and each one went from 8 to 24, and each, like, it adds up. Recursive parsers were actually quite sensitive to this, even in opt mode. Mostly it was the stress tests for recursive parsers that were already living right at the edge of where your stacks could be. But like, these are the sorts of things that you're not going to experience until you actually get, probably a couple hundred, maybe 1,000 changes through the system. So that's why you load it up ahead of time. Additionally, there was an obscure feature of the library that I had totally failed to notice. And like, I went through the full design review process of everything, and nobody mentioned that I was missing a feature. You could create this little RAII thread local class that would suppress the logging of downstream and log variants of the macro. And it was only used by one team. And there's a very special tool that you can use in situations like this. Ask for help. This tool is really easy to deploy and very difficult to deploy correctly. When you ask another team for help, you still have to be willing to do work. This isn't passing the buck. This is like, help me move, we'll move together. Sometimes you won't have to do the work you're offering. But if you're not willing to put in that effort, odds are the other team won't help you. All right, so let's recap how this migration went. I deployed a bunch of regexes to jumpstart. I used Clang's tooling to drive it to the next phase. We used Rosie, our automated changes, to run this through CI and submit tests. We asked for help when we found isolated teams doing unusual things. In the end, migrating 1 million lines of like error handling calls took about 6 months. And that 6 months includes the time required for debugging, implementing, and getting approval for all of the library design. Almost none of my presentations would be complete without some discussion of Swiss tables. My CppCon talk from 2017 introduced them. My CppCon talk from 2019 discussed a bunch of optimizations to them. The 2019 talk also discusses a lot of the more surprising aspects of Hiram's law when doing migrations involving hash tables. I am not going to retread the Hiram's law discussion, except to point out that, oh boy, is it real. I knew from the start of this migration that I was going to have to use Clang tooling to accomplish the migration at the scale we wanted to do. Fortunately, I'd already built a Clang tool to rename classes. So surely this is going to make my life a lot easier. Narrator, surprisingly it did. I was able to basically use the tool that I had written. I was kind of surprised. But hash tables are interestingly different from concurrency primitives. People hand hash tables across API boundaries. Did I see a hand over there? No. People hand hash tables across API boundaries in a way that like nobody hands a mutex or a blocking ref count to a function. They just don't. So there is a most correct answer to how you should handle things like cross API boundaries, which is you should trace the web of connected components that form the graph that is the atomic thing you cannot split. And you have to do this cross-translation units. It's a big join of your graph database. And once you have this accurate connected components thing, you can then feed that into how do you split apart your changes into individual components and submit them. And like that is the correct way to do it. Instead, you could just generate a lot of different changes. And like, all right, I'm gonna split them on directory structure. I'm gonna split them according to whatever. And you let the compiler tell you which of your cookies is burned and needs to be thrown away, and which is that perfect cookie that can be submitted. Remember, cattle, not pets. So when we set up our automated tooling, we can configure it to reject the things that fail without ever bothering a human about it. And I guarantee you, it works on Christmas. We did eventually build out the tools to identify the connected components and like handle them intelligently. But we'd actually migrated about 70% of the hash tables across Google before we needed that complexity. That sentence slipped in two very specific things that I think are worth calling out for general concepts that we're going to want to use in the future. I know it seems like a small word, but recruiting people to parallelize this work can be massively accelerating in these things. Especially if it's the early days and your tooling is a script that runs on workstations, like having a few more of those workstations churning on it, like, is helpful. It's also just, it's motivating to have a community of people. I decided to name the overall effort for this migration Map Marauders because I like having a little bit of whimsy in my life. And weirdly, the fact that I named it Map Marauders attracted Andy to the project. And then from that, Andy joined C++ Core Libraries and then co-founded BrontoSource with me. Like, you never know where these communities will go. And what's really great about them is the people drawn to these communities, they're the high throughput people. You want them on your side. You want their crazy ideas so you can iterate with each other and build. It is not a coincidence that all of the best Renaissance artists knew each other. It's not that they were the best Renaissance artists and then just kind of came together. It's that they built each other's expertise up because they had the right attitudes. And building these communities helps you find the people with the right attitudes. The other thing that I said was 70%. Being able to produce graphs, it shows where you are in the migration and how far you've come. And like, it's dumb, but it's important. It's not only useful when you're talking to the pointy-haired bosses, being like, look, it's really useful for the community itself because we all see the lines move and we're like, yeah, the lines crossed. Like, come on, we're all that dumb, right? Like, we just love watching lines move. So, like, let's recap where we are with this migration. We built playing tooling to get ourselves a really precise migration. We used our automation to filter the bad cookies and keep the good cookies. We built a small community to help drive the migration forward. We have graphs to help us track progress and keep motivated. But I'm actually missing two important and powerful techniques that we used here. Type names show up in extra places that we might not think about at first. If you were just trying to rename unordered map, this isn't a reference to the type unordered map. This is a reference to the type const iterator inside the unordered map. And so we could adjust our tooling to like just do that rename too. But instead, we can do a different, easier migration that will soften the blow for us in the future. Nobody actually wanted to know that type. And now it doesn't matter whether I do a migration to node HashMap, flat HashMap, any other HashMap. Auto is a better name for that type. And the code base just got cleaner. Now you could say, but Matt, why was this not a for each loop? And the answer is like, that migration would have been a harder one. And the entire purpose of this was to do the fast, easy migration that broke ground and set the stage for us. Inside Google, we actually have a term for this sort of approach. It's called buying the gnome. And so back in the earliest days of Frugal, which then became Google Shopping, I know Google's great at names, there was, if anyone who searched for like sneakers or something, this garden gnome that someone was selling on eBay that had big blue sneakers would like show up as the #1 search. And like the engineers involved were like tearing out their hair, and they would block certain images and like find a cache of it somewhere else. They would tweak, and every time they tried to tweak the like scoring algorithm, it destroyed all the other results, and like this gnome was just winning. And then one of the engineers on the team had this brilliant idea. This is like an eBay listing for $200 or whatever, 100, 200, like a rounding error to anyone. And so they just bought the gnome. And the eBay listing went down, and their problem got solved. Right? Like, if reality isn't how you want it to be, just change reality. It's a weirdly powerful technique. The other part that I've actually left implied like throughout this entire talk is hard work. Someone needs to build the tooling, investigate the bugs, because there will be bugs in the tooling, fix parts of the migration that are broken for various reasons, because C++, it do be subtle, and just generally do the work. Even automated migrations require some work, especially if the goal is to drive to 100% completion.
When you're doing an automated migration and like that migration is actually running, how much time per week do you think you actually are spending like modifying the tool to address reviewers' concerns?
In my experience, when you first build out the tool, you're gonna have a phase where like the tool doesn't work at all and you're building it out. And then the tool is able to produce some edits. And usually you want to like produce a few small edits at first to find out where you've got really obvious bugs in your tool. You don't even send those for review or anything. That's just you learning. And then you send them out, and you want to do a gradual roll-up because there will be bugs. And then after you get to the point where you're like, cool, I want to take the like wheels off, I want to take the blocks off this thing and just like let it fly. I end up needing to fix bugs in the tools like once a month. Like it doesn't come up that much once things really get moving.
Along those lines, so you're doing this gradual rollout, you're probably starting in code bases that either have low impact or that you understand really well, so that when it turns out you actually do care about reference stability, you're like, oh, I know why this is the way it is, right?
Yep.
So you come to a team that you don't know them, they don't know you, and you're like, I would like to land this patch set that touches every single file in your entire project. Is there review? Like, what was your experience with those sorts of migrations when people haven't heard of you before?
Very quickly, people come to hear of you.
Okay.
That's the first thing. You do, like, there's a little bit of pushback, and it helps to have an approved document. Like, for the error handling case, like, I had Sanjay Gemwat, who's the most senior engineer at Google, had, like, signed off in the direction. Mm-hmm. And so when people are like, you're touching my macros, I'll be like, talk to the document. Mm-hmm. So it does help to have a little bit of, like, authority behind you. One of the things I find a lot of the time when a team first comes to it is if you talk to them a little bit like people, you'll find out that like what's their actual concern. And like their actual concern may be like, oh man, we're rushing for this deadline in 2 weeks. And you're like, cool, I'm just gonna shoot this change, like kill it, and I'll come back in 2 weeks. They're like, oh, thank you. And then when you come back, they remember you as that nice guy who waited 2 weeks. So like hear their concerns.
Also, version control is part of the foundational.
Yeah. Version control first.
Yeah, but you don't want to get in the fight of like submit, rollback.
Yeah.
And like we've also had things where the automated tool like submitted it and the team rolled it back, and it submitted again, and the team rolled it back, and it submitted again, and the team rolled it back, and it submitted again, and the team rolled it back, and submitted again, and the team rolled it back, and it submitted again, and the team rolled it back. And on the 8th time, they contacted us to be like, stop!
Rollback, block list, fix the issue and address it, then you can go forward again.
Yeah.
Make sure you can roll back.
And so like also bear in mind, like when these people come to you, they're probably having a bad day because you might have broken their build. Like have some sympathy. It's really hard to do because oftentimes when they come to you, it's like 5 people at once coming to you and you're having a bad day. Yeah.
Maybe you'll hit this later, but I find like there's an art in choosing the right migration, and that really helps the conversations too. So
yeah.
Like if you pick migration where you get 0% of the benefit until the last change goes in, then that's a much harder sell.
Yeah.
Unless you're literally curing cancer or something.
Yep.
Like you're much better off saying, well, when you land it, your builds will be 5% faster. Like, well, then they realize they're getting immediate benefits. That really helps too.
Yeah, that's absolutely the case. And actually, like, kind of segues nicely into this next one. I don't know if anyone remembers the episode of The Simpsons where Lisa was getting bullied, and she like goes to like try and figure out why the bully is bullying her, and like eventually figures out it's pheromones, and like one of the other nerds stands up and it's just like, but chemicals are my friend. Like this is kind of how I feel. Like regular expressions are my friend. They would never be the enemy. Hopefully that's not an overly obscure reference, or maybe it just dates me really specifically. So what's the goal for this migration? There's a library called RE, which is a wrapper around PCRE, and there's a library called RE2. And I'm going to take a moment to talk about what these are. RE wraps PCRE, which is a pure C library. PCRE has a few problems. In particular, it has buffer overflows when an attacker controls the regex being constructed. And it has buffer overflows when the attacker controls the string being matched against for some regexes. At least it did the version we had at the time. Maybe these have been fixed at head, but I'm also not going to guarantee you much. PCRE. And it has worst case exponential performance. For those who don't know, PCRE stands for Perl Compatible Regular Expressions. As a fun fact, it is not Perl compatible, nor are the expressions it compiles regular. RE2 fixes all of these bugs. It has the exact same API as RE, and it fixes all of these bugs by not handling all the regular expressions. Sometimes it will just refuse. It will be like, that regular expression requires exponential time, and no, I will not do it. So when Hiram was talking about his sorts of things, Hiram was talking about the case where like, I'm making something that's really supposed to be bit for bit compatible. And now we're talking about something that we know is not fully compatible. When replacements are all compatible, we only need to worry about Hiram and Hiram's law and bugs. When a library is mostly compatible, things are going to get harder. So we're going to need to get all of our tools, and we're going to get all our tools, probably make a few others, and we're going to just deploy them judiciously, injudiciously. We're going to need a plan. So if we're going to have any chance, what's our plan? Step 1, identify how to make this problem not grow without bound. In our case, Bazel has a concept of allow lists. We put all of the existing users on an allow list and refused to add anyone new to it. And anytime anyone asked us, we would point them to the document where Sanjay was like, this is a giant security vulnerability and a time bomb waiting to happen. No. I'm like, super easy. Boom. Allow list. Yeah.
What do you mean user allow list? Is that like an individual or like a
code,
unit or something?
Translation unit. Inside Bazel, you can say like, this library can only be depended on by these 7 libraries. Or in our case, 4,000. Don't be afraid of a 4,000 allow list. As the migration goes, it'll shrink. Julian was a volunteer who just like, I don't know why he decided he really wanted to do this. And I like, honestly, I do know why. He was an SRE and he wanted something that he could do whenever he was on call, that if the pager went off, he could just drop that work immediately, go do it, and no one would be unhappy with him. Like SREs are great for this sort of thing because they sometimes want that work. And so Julian was like, I'm going to push by hand on this. And the first thing he did was he went to Google's fleet-wide profiling thing and looked at what is consuming the most CPU cycles in PCRE. And he went to fix those. Because if you're doing manual work, do it what matters the most, right? The whole point of this is to get incremental wins along the way. And since we're fixing a security vulnerability, CPU cycles spent in the vulnerable library is actually a really good proxy for our vulnerable surface. I went a very different direction. I went around and started to look for all of the weirdest oddballs in our code base, things that I knew, no matter how well I made my tooling, would not migrate. And I applied my favorite tool. I tried to buy the gnome. In this case, I just tried to delete them outright. And like this worked about half the time. Like anytime you're like, oh man, I've come to some code and I can't figure it, like just delete it and see if it gets through CI. Like, I mean, like even at 50% hit rate on just delete it and see if it gets through CI, that's 50% of the work you didn't have to do at almost no thought. The other half, I went to the code owners and I asked for help. And it turns out that these weird little cute creatures, they were actually pretty friendly. The small ones, they just like cleaned themselves up in a matter of like a day or a week. And the biggest ones, they were like, oh man, well, we have a long-term project that will let us get off that. And I was like, cool, can I get you to like priority that project? And they were like, well, that document is signed by Sanjay, so okay. And like they did it over the course of a year. They like migrated themselves off. And in the end, they actually left a chunk at the end. They actually left their dead code behind. And so I did the work, right? When you ask for help, if they did all that work for a year, I'm just gonna delete their dead code for them. It's really not a big deal. And like my delete stats are amazing. Like when I tell you, like this code, this was like a 26 megabyte file, every line of which was a regular expression. And inside their build system, they used gen rules to call M4 scripts to generate code. Like when I said like these were things I knew would never fall to an automated system, yeah. So I love that. I've deleted the most complicated build code I have ever seen. So let's back to the plan. We have the allow list to prevent backsliding. We're spending hard work where it is most impactful for our objective, reducing the security surface. We bought the GNOME everywhere we could. We asked our friends to help us. Now it comes time to unleash the awesome powers of Clang. So I gathered all the Clang powers I could hold in my head, which actually means I took the rename class that I had written earlier and I made a fork of it. And then I was like, okay, so the RE2 class, it has a method on it that you can hand it a regex and you can ask it like, hey, would you do the same thing as RE given this regex? And it will respond with a tri-state of, yes, I am completely compatible with RE on this, or I'm mostly compatible. I am compatible except in a way that I think no one will ever notice. If you're curious, that way is like if you have nested universal quantifiers with new lines and a multi-line regex, which of the like parenthesis groups gets the new line could change. And the other thing could say is like, nope, I will not do that regex. And so now I just need to know how to figure out how to use Clang to call this method. And there are like a bunch of ways that like people set up. Sometimes they just like build their regex with a hard-coded string. And sometimes they're like, no, the proper thing to do is to pull your hard-coded string into a global because you're a better person than that. And someone else is like, no, a const expert function is the correct. And it turns out that in the guts of Clang, every one of these requires a different approach in order to extract what is the string literal. But I don't care. It's three things. I implemented my tool to try one. If it worked, I would use the method to test it. I'd try the next. If it worked, try the third. And so I could get all of these things where I would know this regex is compatible, this regex is mostly compatible, this regex is not. And so what do I do with the non-constant strings? I ignore them for now. That's a problem for future Matt. So now I have a whole bunch of changes that should work, right? I wrote the tool, I did the testing. This absolutely should work. And how can we like scare Hiram out of his like cave? How can we get the depths of him? And unit tests have a wonderfully fascinating property. Unit tests are almost always run in your tests. Almost. And so I pointed this amazingly powerful tool at all the unit tests. And I just ran it through the unit tests to be like, cool, which of you are going to fail on me? And I discovered that RE defaults to the Latin 1 character encoding, and RE2 defaults to UTF-8 character encoding. Don't worry, I have a tool for problems like this. We're just going to change the default of RE. Look, so we could change either default, right? We could change RE2 to Latin 1, or we could change RE to UTF-8. And like, anyone have an opinion of what's better, Latin 1 or UTF-8? You're nodding. Yeah?
Would be a great default, I think.
Yes, UTF-8 is the correct default, and so I decided I'm going to change the default of RE to UTF-8. So who do I have to get approval from? The most senior engineer at Google, Sanjay. The problem is not insurmountable, but like Sanjay is a little skeptical of everything. I think by the time you rise to that level, skepticism is sort of ingrained into you, perhaps beaten into you with hard lessons. So we're going to put in a little bit of elbow grease into gathering the evidence and convincing him that we can do this by asking for help. I created a survey and I sampled randomly 500 users of RE. And the survey said, hey, this regex on this line of code, what character encoding is it matching? How confident are you in that answer? What would go wrong if you were wrong? And then I waited until the survey, and like out of the 500 people I sent it to, I got like 200 responses. Anyone who's run informal surveys like this, 200 is totally enough for statistical significance. And the vast majority of users either used ASCII or didn't know. For those that haven't like snorted the crack of character encodings, ASCII is a proper subset of both Latin 1 and UTF-8, so you're good if it's ASCII. And as it turns out, there were 15 people who said, I am confident that this is Latin 1. So I manually audited all 15 of them. 3 of them weren't using it as the default. They had explicitly specified Latin 1. And I was like, cool. So my migration will work for you because I'll carry that over. Of the other 12, all of them were wrong and were actually using UTF-8. But that gave me enough data to convince Sanjay, like, cool, let's just change the default. And it's important to note when you're going to switch a default in a library like this, like you should leave a global hatch that says like use old default so that the SRE, when it inevitably like rolls out and goes wrong, they can flip this global hatch instead of coming to you and giving you a bad day. And 6 months later, I went back. No one had ever used that global escape hatch because gnomes are stronger than character encodings. So reality is just how we want, and we can go back to unleashing the powers of our Clang tool. This stage went actually really smoothly. The Clang tool sent out like, I don't know, 2,000-ish changes, which given that we had 4,000 changes to begin with, and like Julian has just been like madman typing away all this time, it's pretty good. So back to the plan. Let's review how things were going. We have the allow list to prevent backsliding. Julian really is spending his hard work on the most impactful parts. We're buying the gnome left, right, and center. We asked for help where we couldn't. What's left? As we know, there are known knowns. These are the things that we know that we know. We also know that there are known unknowns. That is to say, we know that there are some things we don't know. Remember, the tool, when it got to a dynamic string, it just said like, nope, that's a problem for future mat. And unfortunately, future mat has arrived. So the question is, how do I turn the known unknowns into known knowns? And the answer is we're going to need a new tool. Dynamic instrumentation. You can only know it dynamically, so I guess we'll have to figure it out dynamically. We're going to make abcel source location and a global logging system hold hands. Abcel source location was a pre-adoption of std source location. So I made the constructor for RE take a std source location : current. And then before it compiled itself as an RE, it said to RE2, hey, how do you handle this regex? And then it would log this file and line handles this regex with handles a regex with this state. Don't log the regex because that can be personally identifiable information, right? But this gives me something, and it'll tell me once I get all those logs what's compatible and what's not. So I just have to use this data to migrate, right? I just have to like scrape the logs. It's really not so bad. The people who run the global logging system were like, hey, how big is the arity of your data? And I said, okay, worst case scenario, we have about 1,000 things here left. It can sort of output data as one of 3 things. So like 3,000 is kind of the worst arity of the counters that we're emitting. And they said, cool, I need you to wait 1 month. And I said, okay. And then I came back in a month and they were like, great, you're good to go. So how's the plan going? We still have an allow list. We're still spending our hard work on the parts that are most impactful. We bought the GNOME as much as we could. We asked for help when we couldn't. We have dynamic instrumentation now, and that was really cool. So what remains? Right, the incompatible cases, right? There were cases where we just knew it didn't work, even dynamically. And we bought the GNOME on a bunch of these, but like, all right, let's kind of like see where we're going to, like, how are we doing? At this point, we have reduced the number of usages from 4,000-ish to 70. As an engineer, the next answer pains me deeply. Sometimes the right answer is to stop the project. We hit diminishing returns. At this point, because of the work we had done, you could not find RE in our like fleet-wide telemetry, PCRE in our fleet-wide telemetry. To the greatest extent you can imagine, we have mitigated this security vulnerability. Well, not greatest, right? There were 70 more usages. But every one of them would have been an individual hand project that probably would have like materially changed someone's feature set. And so we stopped. Like, it pains me, but sometimes that's the right call. So let's review my journey, at least, on this. Right? Hard work actually always rules the day. But the trick to hard work is deploying it intelligently. A mechanism to lock in those wins, prevent backsliding. That's really where everything goes. Just changing reality so that your problems don't occur is just like wildly effective. It has no right to be as effective as it is. Build communities, make friends. These people are great. Make graphs and dashboards so that you can keep your friends motivated and show progress. And like, guess what? It actually goes really well in your promo packet. I'm sorry, it does. Ask owners for help when you're stuck. Use dynamic instrumentation when you're not. But like, that's sort of the set of tools I discovered in my journey. Questions?
How dogmatic are you about whitelists? Because we've done the same thing with customers, right? They're in migration, and the first thing you do is if they don't have a whitelisting mechanism, you set it up because it does everything you said it does. The problem is sometimes you run into this situation where
you remove them from it, and then they're like, but we rolled back that change. Let us back in.
So that's bad. They have a big ball of mud. Yep. Or pick your derogatory term for giant mono code base. Yep. And they start to split it out into smaller pieces.
Yep.
And now, where you had one library on the whitelist, they now have 10 libraries, and they're like, could you please let us in?
So it depends where I am in the phase of the project. Mm-hmm. In the earliest phases of the project, I will, like, if you have a paper cut, I'll let you back into the allow list, right? Like, my going from 398 or 3,998, but to 3,999, like, it's not going to hurt my asymptotic progress in any way whatsoever. For something like that specifically, where they're not actually increasing your surface area, they're just renaming the bit, like, I would always do that. Mm-hmm. Also, like, the hard no answer, that's the one that makes you enemies. And so I try to avoid that. Oftentimes what I will do if I'm in a sort of middle stage of the migration, I'll say like, okay, but can you please open a bug to track your work to resolve this? And they usually do. And then when we get to the end stage of migration where like, this list contains 70 people, and they're like, but my new thing, I'm like, don't care. So, right? Like,
yeah, so Balance.
Yeah. And like, honestly, nothing, just never be dogmatic. It never makes you any wins. Unless you're in YouTube comments, then you should always be dogmatic.
Do you find like if something's too complicated for tooling that like sometimes you can just like get a whole bunch of engineers to buy the no? Like,
yes. A thing I did not talk about in here was a project that I created at Google called Busy Beavers, which was a clearinghouse of projects that were too hard to migrate automatically. It was just like, it was a big clearinghouse of these things. And, we gate kept very loosely the entrance to the project, where like someone would say, like, can I add my thing to the project? And we would say, can I see the directions that you're giving to people? And as long as the directions were something someone could follow, we were like, cool, now you can go onto the list of projects for this. And this like big list of projects that were too hard to migrate, and we like advertised it. Like, people just came out of the woodwork and just like solved these things for us. And we were like, that's so weird. What do they get out of this? I mean, like, I actually know what they get out of this. This was during COVID. We were all going stir crazy. Anything to not think about the fact that the world was on fire. Also, I don't know if you've noticed, the world is on fire right now. A lot of people really don't want to think. So like, perhaps that will help. And so you can definitely do that. Really, like, I tried that with the PCRE, with the last 70 things in a PCRE. I tried to set it up, and I very quickly got a bunch of volunteers that looked through them all and were like, man, these are hard. I was like, oh, well. So it doesn't always work.
I mean, it sounds like even if you're in a company that like tracks CL stats, like just, I mean, it's not a good stat, it's like some people like to do it, but like it's a great way to get like a little bit of code or a little bit of something, get a little bit of success to just be like, this is a really easy thing I can do.
Oh yeah, like the instantaneous dopamine hit of like landing your CLs, because they still think that these cattle are pets. And the other thing is, especially when you're like running the tooling that like does a bunch of these things, people are like, oh man, I submitted 1,000 changes this week. Yeah. And you're like, yeah, that's a great feeling. I love it too. And I'm not going to comment on the fact that I submitted 8,000. As a fun side note, like the Rosie tool that does it, earlier in the days of Google, all of the Rosie users had a single pool of test resources. And there was a period of time where I was using literally 95% of it. And the team that managed Rosie added a feature specifically to be like fair to Rosie users. And they were like, this is the feature to stop Matt. And like any good feature, like they threw it open and they were like, yes. And then something went wrong and they had to roll it back. And I was like, haha, suckers, another week.
So obviously BrontoSource is trying to make the investment to do an automated refactor lower. Do you have any internal heuristic you were using where it was like, if it's like we talked about this a little bit, if you could just do it with regex, maybe that's the right tool.
Yeah.
But if it was something that was difficult, but there were still 500 occurrences of it, was there some heuristic you were like, figuring out the Clang AST is not worth it? Is it here? I'm just going to put this out to the 10 engineers who are going to work on this or something?
Yeah, we tried to avoid the answer of like, it's not worth automating this, but we know how we would automate it.
Mm-hmm.
For that task, what we would put out to the engineers is, here's a chance for you to learn Clang tidy, right? Because like, I actually don't want to disrespect their time. And if it's not worth it for me to do the unautomated task, it's not worth it for them.
Mm-hmm.
And the other thing about like, the reason you start with regex over a more Clang specific tool is that it's easier. It's already there. And like the Clang tool has a really big overhead. But like if there's an existing Clang tool, like Clang Tidy or something, or maybe something that a company like BrontoSource might provide, just use that.
Mm-hmm.
And it will be more precise. And the point is just to bring down that cost to the point where everyone's like, yeah, man. So one of the coolest tools that we developed in Google was a thing called the inliner. And you would just annotate a function to be like, inline this. And then like the thing would go in the background and inline it. Spoiler, we have one at Bronto. But like those sorts of intent-driven things are really, really powerful. And like you should watch Andy's talk. Like super good. Everyone here in this room should build a time machine and then go watch it. Or build a time machine and work forward till when it's on YouTube and then go watch it. Yeah. And like a lot of them, especially if you're in a small scale world and your IDE can just like do it for you, yeah, just do it with your IDE. They made that tooling for you.
On the getting help part,
yeah,
what would you say is the balance of like actively seeking participants versus like if I build it, they will come?
So there are two distinct categories of like getting help. One is the building a community, and one is the like asking the team that owns this to do actual work that's like measured in their OKRs. And like for that one, you should probably spend at least a day pounding your skull into it and deciding that it's worth asking for help. And if after pounding your skull into it for a day, you're like, this would be 3 days of work, keep pounding your skull, right? That's a tool to use when you're like, oh man, this is going to take a quarter. For building a community, I lean towards like build communities early. Especially if there's a thing like Busy Beavers where you can easily advertise it, especially if like, so when we wanted to start the Swiss table migrations, the very first thing that we did was we published guidance that said, hey everybody, we've got these new hash tables. They're super awesome. They do everything you want and make you more attractive to members of the sex that you wish to be more attractive to, right? And they're great. And you should, in all of your new code, start using it. And then we also said, we're also running this effort to migrate and you can join us in that effort. And so you do have to delay your announcement a little bit. But as it turns out, in order to even get approval to like do the Swiss table migration at all, I had to like migrate all of the code, all of web search, just to prove that there was a performance win for it. And like getting approval for these, by the time you've gotten approval to do a migration, you've usually built most of the tooling you're going to need. Does that answer your question?
Yes, thank you.
Do you have you had any experience on like the differences between migrations where there's like some sort of time like deadline or urgency component and the ones that don't?
Yes. So at one point we did a switch from libstd C++ to libc++. And for reasons, there was a timeline urgency to this. And this was a very hard project. We spent probably 2 years as a team, like getting everything right and doing it. And at the last part of this project, I went to every community that I had already built and a few that I hadn't. And I was like, this is the final burn down. We need this list to be as near zero as possible by this date. And we all just like flooded onto it. And then we did it. Like if you're inside Google, search for exigent in the code, in the CL description. Like when you're doing something like that, you want a CL description that gives people a really clear, like, this was like, this will not be rolled back except for the most exigent circumstances. If you wish to ask for a rollback of this, you need VP approval and an active P0 bug that you will work on continuously until we can roll it forward again. Bear in mind, in so doing, we will break about as many teams as we broke doing this flip just to get you like unstuck. And so like sometimes you need to go the hard way. But those are usually the exception, especially if you're dealing with like automated long tail of like, it's the cleanup. You're just like, cool, the cleanup can go for months. And as long as you're like picking up the next projects and getting them on board the trains and stuff, it actually works out.
I just wanted to say, like, I think an underrated tool that didn't come with this talk is spreadsheets. Like,
so that thing I said was like, show graphs. How did the graph start? I had a command I ran at the terminal on the first of every month that just counted how many instances there were, and I put it into a spreadsheet and I would update the graphs. Like spreadsheets are great.
Jenkins jobs with the graphs in them.
Yeah. I've never done I've done anything like Swiss table or any of those, but like just getting your stuff working, you will get a bunch of tests, put it in a document, and then you can like put it into a bug class and then solve all of those. Then like you have to think differently when you're coding at like a scale of thousands of CLs that you didn't write. Like It's just a different experience.
And like one of my dark secrets that I'm now going to unburden to all of YouTube, I don't know SQL. But I am good with spreadsheets. And like it turns out like spreadsheets are just like the mini databases of the world. They're great.
Yeah, you just brought up another thing that didn't come from the talk is the ability to the way you put it, have your CLs require management approval is a really effective tool too. And that's something you have to build though. You don't necessarily have that.
Yep.
It's just
Yeah. And you got to work with the kind of tools you have and think about how to expand your toolkit. The funny thing is when I said you're going to require VP approval, we actually had no way to enforce that. We just wanted to scare people away from asking for rollbacks. I mean, if someone had come with a VP, I would have then made them talk to my VP, and I would have hidden a corner until that blew over.
Yeah, I've had that twice.
But even when you're in that situation where you're not going to yield, don't be a dick. It will never help you.
Well, it might help once. You could use that. It's like one of those cards you don't get to play a lot.
Yeah, say no at least with a little bit of empathy.
Yeah, I agree.
Explain to them why the no, right? Because who knows? Oftentimes it's just some junior engineer who's but you roll back when things break, and this broke me, and so I asked for a rollback. You're did you read the CL description? No. It's okay. We've all had bad days. Thank you. Someone's got to start it.